When you think about flying, you probably picture engines, wings, or pilots, but every journey starts and ends on the runway, the true unsung hero of aviation. Without a strong, smooth runway, planes would never leave the ground or land safely. It's the critical link between Earth and sky, the stage for the magic of flight at thousands of airports worldwide. Every flight, from short hops to long hauls, relies on these strips of pavement. Runways are engineered with incredible precision to handle immense forces and guide pilots in all conditions. Yet most passengers barely notice them, just a blur of lines and lights from the window. Today, we'll uncover the hidden engineering behind these vital structures. How are they designed? What makes them so strong? And what clever features keep flying safe? From deep foundations to the paint on the surface, every detail matters. Let's dive into the masterclass of engineering hiding in plain sight at your local airport. You can't just build a runway anywhere. It starts with three essentials: strength, size, and direction. Runways must support the weight of massive jets, hundreds of tons, over and over without cracking. Engineers calculate the maximum load and build in extra strength for safety. Length and width matter too. Bigger planes need more room to take off and land, and pilots need space to stay centered, especially in crosswinds. The cleverest part? Direction. Runways are aligned with prevailing winds, so planes can take off and land into the wind for extra lift and safer stops. At big airports, multiple runways point in different directions to handle changing winds. All these decisions, strength, size, direction, are made before construction even begins. It's a careful balance of aircraft needs, geography, and weather. Getting the blueprint right is the foundation for a safe, efficient airport. Every detail is planned to make flying as smooth as possible. That's the master plan behind every perfect landing. Building a runway is like making a giant multi-layered cake. It starts with the subgrade, the natural earth, compacted until it's rock solid. Any weak spots are replaced with stronger material. Next comes the subbase, usually crushed rock or gravel, spreading the weight and helping with drainage. Water is the enemy. If it gets trapped, it can freeze and destroy the pavement. The base course adds more strength, often a mix of stone and asphalt or cement. By now, the runway is several feet thick, each layer compacted and tested for perfection. The top layer, the surface course, is high-grade asphalt or concrete, perfectly smooth for safe landings. Concrete is used for the busiest runways. Asphalt is more flexible and easier to repair. Special grooves are cut into the surface to channel away rainwater and prevent hydroplaning. Every layer works together to create a platform that can handle the punishing forces of flight. It's strength, precision, and safety, built from the ground up. Look out the window during takeoff or landing, and you'll see a coded language of lines, numbers, and lights. The big numbers at each end show the runway's magnetic heading, so pilots always know their direction. Bold threshold stripes mark where landings begin. Dash center lines keep planes straight. Touchdown zone markings help pilots aim for the perfect spot. All markings use highly reflective paint for visibility in any light. At night or in bad weather, runway lights take over. White edge lights, center line lights, and color changes warn pilots as they near the end. The PAPI system, 4 red and white lights, shows if a plane is too high, too low, or just right on approach. 2 red, 2 white, perfect glide path. More red, too low. More white, too high. It's a simple, universal system that guides pilots safely, every time. Even the best runway can't control the weather, but it can fight back. Multiple runways at big airports let controllers pick the safest direction when winds shift. Rain. Runways are built with a slight crown and grooves to drain water fast, preventing hydroplaning. In cold climates, snow and ice are constant threats. Airports deploy fleets of snowplows and use special de-icing fluids, never road salt, which damages planes. Sophisticated systems measure runway slipperiness in real time, giving pilots up-to-date info for safe landings. Pilots adjust their approach and braking based on these reports. It's a constant battle against the elements, but smart design and teamwork keep runways safe. No matter the weather, the goal is always the same: a safe takeoff and landing. That's the power of engineering and preparation. Put it all together, and a runway is far more than pavement. It's a marvel of engineering, built for safety. Every layer, every marking, every light is designed to guide pilots and protect passengers. The fight against weather is relentless, but runways are built to handle rain, terrain, and wind. These details work in harmony to create one of the safest environments in the world. Next time you're waiting to take off, take a moment to appreciate the runway beneath you. It's not just a road for planes. It's a silent guardian, ensuring every journey begins and ends safely. The foundation of modern air travel is right under your feet, and it's all been engineered with you in mind.